2 predict, explain, observe, explains today. The first one is they're both with unknown solutions, and we've labeled them A and B. So on your PEOE today, you're going to go through the steps. Can everybody see this, or do you want me to turn the light out? You're okay? You have it in front of you? You're going to get solution A, and you're going to do a hypothesis that involves heating. So if the solution is increased in heat, then make your prediction what's going to happen to that solution, right? Use your qualitative observation skills, which are what? Eyes, ears, touch. Eyes, ears, mouth, and nose. Which one do we absolutely not do? Taste. Okay? Do not taste anything today. So make your hypothesis, your if-then statement. In box number 2, which is one on the bottom, you're going to explain. Give point-form reasons for your prediction. Okay? Then you're going to do the procedure that I'm about to show you and make observations in block 3 here, that's bottom right. What happens to the solution as it's heated? What happens if you continue to boil the solution? Write down all your observations. And then for your final quadrant, the one at the top right, number 4, give point-form reasons for the results, compare the results to your original prediction. So this is familiar, we've done it before, and you all see that it goes in counterclockwise order, right? Okay, so you're going to do 1 for solution A, and then we've got the exact same thing on the backside for solution B. Is that clear? Any questions?
Okay, wait, where are the tapes?
Do you need more?
How much do yeah, just
I'm so behind!
leaked everywhere.
At the bottom of the meniscus, so we need some more.
I'll write down A and B.
Okay, too much.
Did you get it?
So my prediction is that it looks like water. Like from all my senses, I can tell that it's basically looks like water and it doesn't smell like any harsh chemicals. So that I think it'll act like water when it's heated. So it'll boil and then it'll like steam up the glass of the beaker. And then I'll see what happens when we do heat it.
I'm scared it's gonna blow up. It's like leaving
It's just like going all out.
yeah. It's like leaving like a
Now what
red,
does it smell like?
like burning.
Yeah, it smells like burnt marshmallows.
So is this the second time you guys are doing this?
Yes,
Okay.
this is solution A. This one has like little spits.
Oh my.
Oh my gosh. Instead of one like constant bubbling, it's little spits. And it spits like almost to the top. It's just so weird.
Yikers. Oh, maybe I should stay away.
Yeah, I'm Miss Addison.
It's just spit.
Or Mr. Ed?
Yeah.
Is that your name? It's like really orange. It's spit and now it's really orange.
So now, why do you think it's really orange? What has happened?
Water on it?
Making the
Yes, probably. This has come out here,
And
and
it's water.
well, whatever it is
Yeah, the
is
liquid.
on the outside of this, right?
So yeah, okay.
And so therefore, why is that orange?
It's making it wet. I don't know.
Okay, so but well, if this is outside of the test tube,
Yeah.
then this is then
flammable
burning. Exactly. So it's burning whatever's
Gracie,
on
it's
outside
turned a
that
little bit
test tube.
cloudy and it's definitely evaporating.
So for solution A, we predicted that it would bubble and steam because we just thought it looked like water. And then when we started to boil it, it started steaming and then started boiling.
Yeah.
And then it was spitting water to the top, and it
Like
kind
it would like spit and then it would like settle and then like spit again and it would spit out of the beaker sometimes.
Yeah, and then as it started to evaporate more, it started to leave like a kind of like salty kind of residue
Like a
on the
residue
side.
on the beaker, like it's like cloudy.
Yeah.
And then like when the last little bit was boiling, it smelled like salty, like
Yeah.
it smelled like the ocean, which like it could be baking soda, but we really think it's salt. And like at the bottom, if you like look in, there's like little like crystals or something in there that could be salt. So that's what makes us think that, because something was left over. And so that's what we think. And then for solution B, we thought, like we predicted, that it was also going to just like burn like water because it looked like water and we couldn't smell anything, like any harsh chemicals. And then when we started to burn it, like it like started out like water, but then once you burned it for a long time, it like went like yellow, and then it went like kept getting darker and darker until like it had become like a black substance. And like it left like a almost like a, it looks like honey or something on the sides. And like when you burn a marshmallow and it smells like marshmallows, and like when you burn a marshmallow it turns black like this, which like makes us to believe, because marshmallows are all sugar, that it's like water and sugar, like a sugar substance.
It turned into, it was a liquid and then it turned into like a dark, solid kind of.
Yeah, because all the water like left, and then
Yeah.
the sugar is like left back in there, like the burnt sugar. So maybe like sugar can burn and salt can. I don't know.
One of them spits. Which one spits?
B.
B? Really?
Yep.
Not A?
No. A was kind of all over the place, but it wasn't like shooting out like B.
Okay, good observations. Did you write that down?
I wrote the B exploded. It like shot. Yeah.
It was that it like started fizzing right away, and then it quickly boiled. Then the water started to evaporate really fast, and the water turned to a white foam. And then after the water's gone, all that's left is the white foam. And then when you let it cool, it turns into this weird white powder.
Dude, it's actually smoking. Burn.
Light this one.
And that's observation A.
Yeah.
Yeah. Okay, my theory is that if we put it over the heat, that it will boil and then steam will start to come off and it will have a gas that will start to smell because the steam is releasing gas into the air.
Okay, my theory is that if the solution A, when it is heated, it will possibly bubble at a high enough temperature and it will release little to no smell. And my reasoning is that usually things that have a pretty terrible smell are often flammable and dangerous around heat. So I feel like that would sort of be the type of solution we'd be testing.
There we go. We got it. Alright, ready?
Hottest part of the flame. Get away from yourself.
I know, it's hard.
Point it that way.
I'm trying to like not touch the flame. Oh yeah. Some bubbles are starting to come out.
It's starting to steam too.
Yeah, it's getting really cloudy. Oh, Emily, it's starting to like pop. Steaming.
I didn't think what the sound it would make.
Whoa. Should we pull it off soon? I don't want to like make it blow up.
Yeah.
All right.
And then just place it back.
I'm gonna give it a while to cool off. Here, let's turn that off quick. Yep.
Okay.
All right. So.
With observation A, we noticed a strong smell near the end when the solution was getting closer to being more dissolved, and we noticed a lot of steam and some type of crystallization forming on the outsides of the test tube.
Yeah, because when we left it on the first time, we only left it on for about 2 minutes because we didn't realize we had to wait until it evaporated. So for the 2 minutes, it didn't smell as much, and then we put it on until evaporation, the odor became stronger because there was more sugar crystals.
Okay.
Well, it's kind of weird to see like the bubbles. It kind of like one big bubble just goes up the tube.
Yeah.
For B, we believe it had sugar crystals instead of salt, which we originally predicted. But the sugar seemed to grab onto the glass and it actually burnt. So it's like when you're baking and stuff like that, it starts to caramelize. And it's called a chemical change. You can't reverse what's been done. With the salt, you can. Like, you can put water back into it and the salt will dissolve and it will turn back to its original state. But the sugar can't be reversed because it's burnt and you can't change that.
I think, yeah, the only difference is with the salt solution, which was solution A, it was a physical change because, like Hannah said, it can be reversed by just adding some more water, but solution B was a chemical change. So once the sugars have hardened inside, it cannot be reversed. And I think that's all.
We get a different burner, maybe this one's plugged.
First one, but that's after I did the experiment.
Okay, so that was after quadrant number 3, the observation.
Yes.
Right? I noticed on your page though that you had drawn a picture in your predict quadrant right there. What did you have coming out of the test tube top? Steam.
Yes.
Okay, so you predicted that there would be liquid going from, water, a solution going from liquid to a gas. So we had to change a state as a prediction. Good. Jacob, did you want to add anything?
No.
She said it all?
Yeah.
Okay, and then Bella even went so far to say that she thinks it's salt in test tube A. Does anybody else feel that way? Can somebody other than Bella explain why they think it's salt? Yeah, Danica.
Because of the crystallization when the liquid was boiled and when it was gone, what was left looks like salt.
It looks like salt. Okay, you have the white residue on your test tube that looks like salt. Good, yeah.
When it first started turning it evaporated more when it was getting to the bottom, and when we took it off, it smelled salty, almost like the ocean, something nasty, and it didn't smell very good, and the whole thing kind of turned white. If you I think on your counters if you leave salt or something like that with water, it turns white residue.
Good. So both.
How it dried up.
So Matea says that she has seen that before, that if there's salt water that spills on her counter, there's a white residue that's left over after the water dries. Okay. What could you do to maybe test that it is or isn't salt? Is there anything you can do that's not tasting it? Nick?
Is it those strips? Or no, is that for acid and bases?
Acid and bases, so a salt won't come up on an acid or base test for that. Go ahead, Josh.
Wafting it?
Wafting it, so giving it a smell. Maybe you just identify just from smelling. Gracie.
Really like the same experience with salt in it, see if it does the same.
Okay, so yeah, put a known, something that you know is salt into water and do the same thing and see if you get the same results. Good, repeat your experiment. Great. Okay, so with that thought in mind, what if we added water to test tube A right now? Now that you have water evaporated out, what do you think would happen?
Salt.
It would go back to salt water?
Yeah.
And you'd be able to repeat the experiment?
Yeah.
You think so?
Yeah, because it's just the water that boils off.
Okay, so if we have time, let's try it. Let's talk about test tube B now, though. What did you see with test tube B? I'm going to go over here. Yeah, Riley. Let's start at the beginning. What did you predict?
Well, I just predict that it would boil.
So did you make that prediction before or after you saw what happened to A?
Before.
Before. Who made a prediction before they saw what happened to A? And who made one after they saw what happened to A? Do you think that would influence your prediction for B?
Yeah.
Okay, and I never said to do it in either order, so that's okay too. That's part of inquiry, right?
Connection to test tube A when I'm sick and I have to put salt in my water to gargle it. That's the look it had with this.
Good. Yeah, Jake.
Oh, and when we boiled this one, or no, solution A, the test tube it filled up with steam, and the other one didn't.
Right away, you saw steam in the test tube
Yeah.
in test tube A, but in
And
test tube B, you
it
didn't.
boiled a lot faster.
Boiled a lot faster. Good. How was, I noticed that some people were making observations about how test tube B was boiling. Was it boiling similarly or different? Yeah, Anthony. It exploded?
That's what yeah, that's what A did for us. So we found that A did nothing bad for us. B
Okay, so Emily was noticing rings on test tube B that were kind of floating up. Okay, so that definitely has to do with the substance that was in it.
Can I go to observe for B?
Yes, please do.
So I said once the water particles had evaporated, we could see these, it was like black.
The solution started to change color.
Yeah, and we said that the smell was kind of like marshmallows, and the main ingredient in marshmallows is sugar, so we were thinking maybe it was sugar and salt. So we're
Great. Does anybody else agree with what Brianna had to say?
Yeah.
You all thought that maybe it was sugar in there? Good. Okay, so let's talk about B some more. We talked about A. We said that we would maybe be able to reverse this by adding water and redoing it. Do you think that you can do that with B?
No.
It's like burnt.
It like attached itself to the beaker.
And it's all stuck to the test tube? So test tube A is a physical change. You're changing a state of something, you're just boiling the water off into a gas vapor, and the salt is left behind. The test tube B is a chemical change. You see a color change and you can't reverse it, right? There's no going back. All right? I see some of you writing these down on the side in the margin, which is probably a good idea. Let's write down the keywords chemical change and physical change. I'll come back, Emma.
A physical change can be reversed, is that what you just said, right?
Yes.